Yes. Did someone say something?
Yeah, I did.
Yes.
Earlier when I asked you that question,
Yes.
I still don't know what you mean. Like, can you give an example of what we'd have to do for that?
For 21G?
Yeah, like I can probably do it. I just don't know what you mean.
Sure. Yeah, we'll go back to that. Okay. So let me just make sure that I'm recording here. Okay, I am. Let me share my screen for you. Screen. Okay. So just to check, can you guys see my class notebook?
Yeah.
Okay. And you can hear me okay? Yeah, okay. All right, so here's some stuff I put together just to start. I thought it would maybe be helpful just to quickly go over the different types of factoring that you might need to know for tomorrow. Again, you're not really going to have to factor anything bigger than a quadratic, but just to be safe. So factoring out a greatest common factor should hopefully be something that's straightforward, but on the off chance that it's not. Remember, if you're factoring out a greatest common factor, you would, of course, want it to be equal to 0. On the example on the left, 3x squared plus 6x, you would factor out a 3x. The example on the right, you would factor out a 5x. Once you have your two parentheses, or in this case, your one parentheses and your one thing out front, you would go ahead and set both of those equal to 0. Then you would go ahead and solve. In each of these cases, these would be your roots or your zeros or your x-intercepts. And in both of these cases, they would all be multiplicity ones because they're all answers ones. Here in the middle, these are your trinomials with the coefficient equal to 1. So again, you can't make any decisions until you're equal to 0. When you have just a positive 1 in front of the leading term there, you're just looking for two numbers that multiply to be the back and add up to be the middle. Once you go ahead and find those factors here, you would set each of those parentheses equal to 0. You would get your solutions. And again, in each of these cases, they would all be multiplicity ones. Keith, this is kind of going back to what maybe you were asking, like what the problem was saying, work backwards. Like if I gave you 3, you would have to be able to write x minus 3. If I gave you 7, you would have to be able to write x minus 7. That's really all it's asking you to do. So I don't know if you're like making it harder than it needs to be. But if that still doesn't answer your question, we can go back to it. But any questions on anything so far, guys?
Just about 21G now that is brought up, would you multiply out all the factors and then get a polynomial that would be the answer?
So if I asked you to do it in standard form, yes, you would multiply them all out, but I am unlikely to ask you to do that tomorrow only because it takes a lot of time without really a lot of payoff. Like multiplying it out, that just shows me whether or not you know how to multiply polynomials, which I'm assuming that you can. I would be much more interested in seeing the factored form. And then if you need it, this is just a review of the AC method. Remember that the AC method is what you might use when you have something greater than 1 out front. Some people might also be using a guess and check method of some kind. I don't really care what you have to do in order to get to this factorization and these factors, as long as you can do it. But this is how you might have learned it. I'm using what's called the AC method. So if you're going to do the AC method, here are the steps. You're first going to multiply the A times the C. That is the leading coefficient times the constant. So in this example, 12 times negative 6 is negative 72. You would then need to find two numbers that multiply to be negative 72 and add up to be negative 1. So that would be negative 9 and positive 8. Once you find those two terms, you're going to go ahead and rewrite this negative x using these two values, which is how I get negative 9x plus 8x. Once you have split up that middle term, you're going to group the first two, then you're going to group the second two, and you're going to pull the greatest common factor out of each pair. So in the first two, you pull out a 3x. In the second two, you pull out a 2. This is how you know you're getting it right, that repeat factor. If you have that repeat factor, that's one of your answers. Whatever you have on the outside is your other answer. And again, you would set each of those equal to 0. Here would be your zeros or roots or x-intercepts, and they would all be multiplicity 1. So in addition to this, the only other thing that you have to probably know for tomorrow is the difference of squares. Remember, as I told you, you guys don't really have to do any of the heavy duty factoring. We'll save that for later in chapter 2. So the difference of squares would be something like x squared minus 100. That's going to give you the square root of the front in the front, which would be x, the square root of the back in the back, which would be 10, one positive, one negative. And then just so you know, you can actually apply that to non-perfect squares. So let's say that I told you that it was x squared minus 10. By the same token, it's the square root of the front in the front, which would be x, the square root of the back in the back, which would be the square root of 10, and again, one positive, one negative. So any questions on any of those 4 factoring techniques? Since not, I would just say if anyone is watching this on their own, you can try these 2 problems as practice if you do need some extra factoring help. So for those of us who are here, if you're good with that, this is then here just a reminder about the quadratic formula. So you do have to make sure that you know the quadratic formula tomorrow. So here it is, just as a reminder. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, you can only solve this when it's equal to 0. And you will want to, of course, simplify. So if you take a look at the one on the left, it's just showing you all the different components. Things to make sure you do the opposite of b. Make sure that you square b in the inside. Make sure that your division bar goes all the way across. And make sure that you multiply by 2 times a to get the bottom. I would recommend calculating underneath the square root. 100 minus 60 gives you 40. To simplify a perfect square, you need the biggest perfect square in 40, which would be 4. The square root of 4 is 2. Once you get down to here, if you have something common to all of the outside numbers, you should reduce. In this case, you reduce them all by 2, which gives you this as your final answer. That is technically 2 solutions, which you could separate out, or you could just leave it as a plus or minus. Over on the right, they show you the same exact procedures, but notice that in this case, you wind up with 2 imaginary solutions. So again, the quadratic formula should hopefully be something that's easy. You should certainly not have to do it more than once, if at all, tomorrow, because kind of the whole point of this is that things should factor. And then maybe kind of just going back to, again, what Keith was saying. So Keith, if I give you things like 3 and negative 3, you can easily convert those to x plus 3 and x minus 3. If I were to give you something like here, negative 2 plus I, you would, of course, have to immediately write negative 2 plus I, because these would have to come in pairs. If you want to take those 2 and you want to write an equation, you would have to know the equation x squared minus the sum of the roots times x plus the product. And this is actually good because we can see the problem backwards and forwards. So to see the problem forwards, you would have to use the quadratic formula. To see the problem backwards, you're going to find the sum. So what happens if you add negative 2 plus I and negative 2 minus I? If anyone wants to help me. What happens?
If you add them, you get negative 4.
Okay.
And multiply, you get negative 3.
So 4 minus I squared, which becomes 4 minus negative 1, which becomes 5. So just be careful with your i's. And then again, here's the formula. So you're going to do x squared minus the sum. So minus negative 4 becomes plus 4 plus 5. And if you go back to the original problem, that was indeed the quadratic. So fancy how that works. So this is definitely an important formula. I mean, in every one of my periods, we have now done, I would say, at least 3 problems like this. So I do think that it's important. Questions? No? Okay. A little bit about the intermediate value theorem, or the IVT, only because people asked me several questions about it. So I just want to make sure that the two separate implications are clear. So for the intermediate value theorem, this is one of the applications. Notice that A and B are the X values. A is the smaller one, B is the larger one, and they're telling you that C is some X value between them. Then you would have f of A, which would be down here. You would have f of B, which would be up here. This application of the intermediate value theorem says if you go from f of A, which is a negative, to f of B, which is a positive, the only possible way that you could do that is if you cross a 0 or an x-intercept in between. The second application of the intermediate value theorem doesn't specifically talk about a 0. It just talks about anything. So again, suppose you have some A and you have some B. You have some Y value at A and you have some Y value at B. If you had a value of X between A and B, you would have to have a value of Y between A and B. So these are the two different applications of the intermediate value theorem. This one is the most helpful because, again, this is where the sign change comes in. But this one is equally important in certain circumstances. So because I had so many people who asked me about the intermediate value theorem, I figured it couldn't hurt to give it another look here. So any additional questions I can answer for anybody about the intermediate value theorem? And I would say for any question that you're doing with the intermediate value theorem, you just want to be extra careful of your X values versus your Y values. Make sure you know that anything inside of the parentheses would be your X, and then anything on the other side would be your Y. So something else I thought would be helpful here. So I have this graph here, and I'm going to go ahead and talk about a bunch of different things. So first of all, looking at this graph, could you tell me what the degree is? 1, 2, 3, 4, 5? 4. Okay. The reason why you would know that is because you can see that the graph is crossing the x-axis exactly 4 times. Each of those crossings counts as an M1, so that's how you know that there would be 4. I want to just talk about specifically in this iteration, I want to talk about the relationship between the graph and the table. So if you notice each of those x-intercepts, if you look at the graph, here's -3, 0, here's -1, 0, here's +1, 0, and here's 3, 0. So again, please make sure you know that in a table, if you're talking about an x-intercept, a 0, a root, or a solution, all of those kind of mean the same thing. Those are all the blues. Just to be clear, what does the yellow represent? If someone can tell me.
Y-intercept.
It's the y-intercept. If I was going to find the equation of this polynomial and I knew that it was going to be y equals something x to the 4th, where in the equation would the 9 show up? At the end. So no matter what had to go in between, I'm going to end with a +9. So very important that you know that anything that's 0, something is the y-intercept. That is the constant value that appears at the end. And of course, this is the y-intercept that's right here. Something else that would be worth talking about here is, again, going back to the intermediate value theorem. So take a look at -4. Take a look at -2. If I didn't know that -3, 0 was a root, like if it wasn't in the table, why would I be able to be sure that there was a root between these? What about those two ordered pairs, -4, 105, and -2, -15? Tells me that there has to be an x-intercept between -4 and -2.
There's a sign change.
Sign change. So any questions on that? Okay. And then just in terms of the other values, like if you're looking here at the fact that 2, -15, just make sure you understand that, like, even if you didn't draw this entire graph, if I told you that f of 2 was equal to -15, that's how I would get that value. Over here, something like 4,105, even though you can't see it, that would mean that up here, there's a point, and that would mean that f of 4 is equal to 105. So again, I want to make sure you understand how the table connects to the graph, how the function notation connects to the table, and just how everything kind of goes together. Any questions on any of that? Okay. So then again here, same graph, same table, but I just wanted to draw some other things on it. So again, in terms of the behavior and the vocabulary, just to make sure, this here and this here, these would be examples of minimums. Remember, we're used to calling them relative minimums, although in this case, they would also be absolute minimums because the graph doesn't go underneath them. Up here at 0, 9, this would be your maximum. In this case, it would only be a relative maximum because this arrow and this arrow implies that it goes up forever and ever and ever. So we want to make sure that we know that. Some other things, make sure you know that from -2 to 0, I could say that the graph was increasing. You're going to use parentheses only, and then you should be able to go through and tell me where the graph is increasing, decreasing, or any of that good stuff. What about a point of inflection? So a point of inflection is where there's a change in concavity. So can anybody tell me where they think a point of inflection might be? Get rid of that for you.
1, 0.
So 1, 0, I would say that this would be a good point of inflection. Does anybody see a different one?
-1.
And I would agree with that. So again, concave down means the water would spill out. So here would be my concave down, and then here would be my concave up, and here would be my other concave up. So we mostly talked about that on the last quiz, but I still think it's good to talk about again. And then if you wanted to get into the actual specifics, writing the equation as it were. So I would call this f of x. Remember, you should put an a out front. To get this -3, you're going to write x plus 3 to the first. Then you're going to write x plus 1 to the first. Then you're going to write x minus 1 to the first and x minus 3 to the first. And again, you don't have to write the first, but you could if you wanted to. In order to solve for a, you now need any additional ordered pair besides an x-intercept. So again, sometimes the y-intercept is useful in this case, or you could just pick any other value. So if you had this table, you could pick anything except for an x-intercept. So you would have lots of different options. So any questions on that? I just want to take a quick peek here, see if anybody else joined us. Okay, oh good, Jonas, look at this, period 6. I guess I'll have to give you guys the easy version since there's so many of you.
Better. And because we're the best class, but yeah.
Well, okay, so any questions on that? Okay, and so something else that I want to point out here. So again, this is end behavior, up, up. Make sure you also understand with the infinities, the way that you would say that over here is as x goes to positive infinity, y goes to positive infinity. Over here, you would say as x goes to negative infinity, y goes to positive infinity. So again, making sure you understand where the up, up comes from. The reason why it is up, up is because it is even positive, which means that if you were going to solve for this a, it should be something positive. Okay, I think that pretty much covers that. And then finally, each of these is a real x-intercept. Not only are they real, but they're also rational. Just make sure you understand the different terminology. So if you take a look here at this green one, what would you say that the degree of this polynomial was?
3.
3. Remember that a 3 is called a cubic. If you take a look carefully here, this appears to be, a little bit less than -1. It would have to be a nice terminating decimal in order to be a rational number. So let's say that this was -1.25. -1.25 could come on its own. And then the fact that it does not cross the x-axis anymore means that this is your real solution, which is 1, which means the rest of your solutions have to be imaginary. So this is where those solutions would be. The fact that you have a turning point without actually crossing the x-axis means you have imaginary solutions. And specifically in this problem, how many imaginary solutions do you have? 2, because they have to come in pairs, and you have to add up to a total of 3. So again, this is real and this is rational because -1.25 is a terminating decimal. You would then have 2 imaginary that don't cross the x-axis. You could compare that to over here. Again, notice here that you have 3 real zeros. In this particular case here, it clearly looks like you're going through 1. 1 is a real rational number. Then these other values, these could potentially be 2 irrational values, which would still be real. But again, irrational values have to come in pairs. So these could be things like plus or minus the square root of 2, plus or minus the square root of 3, basically anything that doesn't give you a nice terminating decimal. So those are all the questions or all the concepts I thought would be helpful based on what people were asking me to go over during class. So now that I have shown you what I think is helpful, can I answer any specific questions for anyone who's here?
Could we go over 12 from the review packet?
Sure. Oh, just one second. Okay. So to be honest, I think 12 is probably not exactly the type of min-max problem that you'll see tomorrow. I would focus, so 12 is an example of a min-max problem. Just so you know, whenever you're doing a min-max for a quadratic, which is all you might see tomorrow, you're either going to use the graphing calculator or you're going to do -b/2a and you're going to find the vertex. I would say that you should focus on 11 and 13. That is probably much more like the problems that you're likely to see tomorrow, but I will, of course, do it. So you have a vineyard, and it is found that, make this a little bigger here, okay. So you have a vineyard, and it is found that each grapevine produces 10 pounds of grapes in a season when 700 vines are planted. This is a big calculus-y type question. You saw questions like this back in Algebra 2, but maybe not for a while. Basically, if you have 700 vines that are planted, you are going to make 10 pounds per vine. So that's why you have 700 in the first one and you have 700 and you have 10 in the other one. This first parentheses represents the number of vines, and this second parentheses represents grape production. I can't remember what class I was talking about this in, but if you had, a 10,000 acre vineyard, you might think to yourself, well, maybe I should just plant as many vines as possible. But the truth is, at a certain point, those vines have to share the water and the nutrients and the soil. So you're trying to find that perfect number where you can maximize your grape production for every single one of your vines. So you're starting with 700 and you're getting 10 pounds of grapes each. Turns out that they do a study where for every additional vine that you plant, the production of the vine goes down by 10%. So for each additional vine that is planted, additional means plus. Since you don't know how many to plant, we're just going to call that a variable, which in this case, n. Every time you plant an extra vine, the production decreases by 1%. So decreases means subtraction. 1% is 0.01. And again, you don't know how many times that's going to happen. So that's why you have to call it an N. At some point in your life, you did have to write this equation from scratch. We haven't really done any like that. So if I was going to give you one like this, which again, I don't think I am, I certainly would not ask you to create that equation. But now that you have that equation, if you were trying to figure out the number of additional vines that should be planted, then you want to tell me how many vines should I have total in order to maximize my grape production. So again, you could type this into your graphing calculator as is and find the maximum, or you could multiply this out. So if you were going to multiply this out, you would get negative 0.01 n squared. If you were to do the outers and the inners, I believe you would get 3n. And then if you were to do the last, you would get 7,000. And again, that's just by foiling and combining like terms. In order to solve for the vertex, you would do negative b over 2a. I guess in this case, it's actually n equals. So that would be negative 3 over negative 0.02, because 2 times negative 0.01. And if you went ahead and did, oh, sorry, I was grabbing my calculator here. I'm just doing this from memory because I don't have my answer sheet. So negative 3 divided by negative 0.02, you would get that n is 150. So what you just solved for is the number of additional vines that should be planted. What they wanted to know is what is the total number of vines. So if you originally were planting 700 and you plant an additional 150, that means that in total you should plant 150 vines. So again, in terms of what you might see tomorrow, I do not think you're going to see something like this. But the idea of finding a maximum or minimum, yeah, you definitely will see something like that. So as long as you understand the bottom half here, I think you're probably okay. That's a good question. Are there others? Anyone?
For ones that would require mins and maxes, are we going to be able to use our graphing calculator?
Maybe. If it was something without, it would have to be a relatively simple calculation. I mean, again, in this case, I would not expect you to know what negative 3 divided by negative 0.02 was. If the calculation was negative 20 over negative 4, I would expect you to know that calculation. So I think that that's reasonable. What else? If anything?
Could we do 11?
Okay. And again, I think we might have done this in one of the periods, but it doesn't hurt to see it again. Find two positive numbers whose sum is 100, and then you want the sum of their squares to be a minimum. So if you're talking about two positive numbers, I would say, I'm going to say that number 1 is going to be x, And I would say that number 2 is going to be y. So I have my 2 variables, x and y. If their sum has to be 100, that means that x plus y has to equal 100. Then, if the sum of their squares is what we're trying to minimize, the sum of their squares means if I square x and I square y. So again, in this problem here, just to reiterate from using some terminology from earlier in the chapter, this is what we call the primary equation. This is the one that you're actually going to solve, where this would be called the secondary equation because it's really just the helper. If you're trying to minimize this equation, you can't have x's and y's. So you have to take this equation here and you have to solve it for x or y. It doesn't matter which one. I'm going to solve it for y, which means that y is going to equal 100 minus x. If I plug that into my equation, I'm going to get 100 minus x squared. If I go ahead and FOIL this, 100 times 100 is 10,000 minus 200x plus x squared. Combine the x squareds, there are 2 of them, minus 200x plus 10,000. So before I go any further, any questions about how I got to there? Okay. And so then again, if you're trying to, in this case, minimize, you know that it's still the vertex, negative b over 2a. So in this case, it would be 200 over 2 times 2, which would be 200 over 4. Going back to what Zach asked, can you do 200 divided by 4 without a calculator? And if so, what is it? Should be 50. So this is x. There was some debate as to whether they actually asked for y or not. It did technically say find 2 numbers. So that would be 50 and 50. And then remember, you were actually trying to minimize your square. So that means you want to plug a 50 in for all your x's. So if you set x equal to 50, you are going to get a sum of 5,000. And that's from here. So again, it's very clear on the test what you have to solve for, what you don't need to solve for. If I want you to find the dimensions or the values, I will say it explicitly. So x is 50 and y is 50. And then again, what is the sum? The sum is 5,000. Other questions? I know there's not too many of you guys, so consider this, a little private tutoring sesh. Let me just see if there's anybody else that joined us. Oh, just 6 people. Huh, because everybody's busy. Anything else I can do for you fellas? Any other problems that are giving you pause? Again, I do think that the review sheet is a pretty good representative sample of what you're going to see tomorrow. I think that some of this stuff I did at the beginning here, reviewing for you the terminology and the different types of roots and the table and the factoring, that is all stuff that you should know, but perhaps just seeing it an extra time does help. Intermediate value theorem, remember 2 technical applications, one for a sign change and then one just telling you about the y values. How to work backwards, specifically when you're given imaginary or irrational solutions. This is a very easy equation to memorize and really a pretty easy equation to use. As far as factoring goes, you don't have to do anything more than a quadratic. And if you are going to do the quadratic formula, you certainly should not have to do it more than once. Notice we didn't really do any synthetic division here because I do think that you guys are pretty good at that at this point. And in terms of the rational root theorem, so actually somebody sent me a message earlier about the rational root theorem. So just to be clear, the rational root theorem is your very last resort. The question that somebody asked me was, how do you know when to do the rational root theorem versus how do you know to do the other types of factoring? So again, I have already told you now, the only types of factoring that you're going to see tomorrow is quadratics. So these are really the 4 types that you would have to look out for: a greatest common factor, a difference of squares, a trinomial with a coefficient of 1, and a trinomial with a coefficient greater than 1. So if it was only 2 terms, you would try one of these, and I think the difference of squares should be pretty obvious. If it was a trinomial, you're either going to have a 1 out front or you're going to have something bigger than a 1 out front. Again, going back to the rational root theorem, it is very unlikely that you will see many, if any, that you actually have to list and test the P's and Q's. I am more likely to give you a problem where I would tell you an X that works and you would just have to prove it and show me. But the reason why you would use a rational root theorem is if no other method works. And additionally, the question would specifically talk about rational roots. If you say the word rational roots, that is kind of a dead giveaway that you might want to think about using the rational root theorem. But again, the idea of testing a whole bunch of things and having to find the one that works is definitely not something you have to worry about for tomorrow. Anything else? Nothing? Okay. Let me just go back here and then say a couple additional things. So if you have your test tomorrow, first block, remember, try to get to class as soon as you can after homeroom. You'll be able to start as soon as you enter, and then you get the full 50 minutes. If you are the period before lunch, again, try to get there as soon as you can. You can start and then take a minute or 2 into lunch. And if you're the period after lunch, you can come in at 11:25 and then start from there. Homework is due tomorrow night, but again, focus on studying for tonight. I don't think there's a whole lot to memorize in terms of formulas. The quadratic formula and the x squared minus the sum plus the product, and I guess the end behavior, but I would think at this point, it's kind of like muscle memory. Anything else that I can answer for you lovely 6 people who have joined me on this beautiful Tuesday night, Monday night? Anything? I think it's a good test. It's comprehensive, and I would just say, the whole first page is multiple choice. There are some that you'll be able to do in 30 seconds, and then some that you might take a few more minutes, but definitely focus on the problems that you know how to do. And if there's something that you're unsure of, skip it and then come back to it if there's time. So I'm happy to answer any other questions that you have, but if you don't have any, I guess this is a good place to end it. But anything else that I can do for you guys? If not, I thank you for coming, and I'm going to post this so everyone else can, get the benefits of your questions. So I do appreciate that. But again, I'll stay till I'm the last one. Otherwise, just try to study as best you can.
Thank you.
All right. Thanks, guys.
Thank you.
Have a good night.
Thank you.
Thank you.
Bye.